All right, for question number 13 onwards, we have now moved to section 3, and this time the type of question in section 3 has been introduced for the first time in JEE Advanced. And you see there is quite a different fashion. Let's try to see. For question number 13, 14 and 15, there is a single chart, and on the basis of this chart, we'll have to answer 13, 14 and 15, and for every question, there is one correct option. The question is, a charged particle, electron or proton, and I would be representing in my shorthand way later on, electron as E minus, proton as E plus, just to make it space effective, is introduced at origin with an initial velocity v. यानी charge of consideration या तो electron हो सकता है या तो proton हो सकता है, and it has been thrown at origin with initial velocity v. Column 1 gives the cases. Column 2 electric field के value दे रहा है और column 3 magnetic field के value दे रहा है. And on the basis of this, question number 13 is, in which case would the particle move in negative y direction? The y cap is the negative y direction, what we also represent by minus j cap, equivalently the same. यानी कौन सा ऐसा combination है after which the electron would move, or the particle more precisely, in negative y direction? The first combination is 4 2s. You could see. Let's see 4 2s, and be careful with the Roman numerals. This is capital case, small case and alphabetical. Let's see 4 2s. Initial velocity of proton is along x direction and the electric field is in y direction. So you could say, due to the effect of electric field, the motion would be parabolic and s is in z direction. So this is a very complicated condition. We can't expect that finally the particle would move in negative y. The second option is 2 3q. 2 3q. You could see initially electron is in y, where the electric field is along x and magnetic is along x. So this would also not give the desired answer where the particle would move along y, because you could see the motion would be a bit complicated one. Now let's go with the C option, 3 2r, 3 2 and r, and this is giving out. क्योंकि initial velocity of proton 0 है, with the electric field in negative y direction, of course the proton will move in negative y, that's the effect of electric field, or magnetic field is along y. So it's something like this, say electric field is in negative y direction, the magnetic field is also in negative y direction. Now quite obviously initially the proton is left at origin with 0 velocity. Electric field ke influence mein it would start coming down, and that velocity would not be influenced by magnetic field because that v and b would be parallel. So finally you could see this is the case where the particle would move in negative y direction, and correct option for question number 13 would be option number C. Now I'll keep this as it is because I require it for the reference, and we'll go for question number 14. Let's move for question number 14, and it says, in which case will the particle describe a helical path with axis along positive z direction? तो हमें चाहिए helical path, और उस helix का जो axis है that should be along z direction. The first one is 2 2r. So let's see, the 2 is electron is given velocity along positive y direction, and the second part, the electric field is in negative y direction, and r, the magnetic field, is also in negative y direction. There is no question of a helical path. The path would be straight line. The second option, let's try to verify. 4 2 and r. So 4 is proton with velocity along x direction. Second is the electric field in negative y direction, and r is magnetic field again in negative y direction. So this would not give a helical path because it would be a very complicated path, but yes, Without magnetic field, that would go in a parabolic one, and initially the magnetic field and velocity is perpendicular. After that the angle would vary, it becomes a complex one, so let's not comment on that. Option number C, let's try to see. 4, 1 and S. 4 means proton is given velocity along this direction, and 1 is electric field along Z direction, so the Z direction would be out of the plane, so that is the electric field. And S option, which says magnetic field is along Z direction, so the magnetic field is along Z direction and the particle is proton, so this would purely be a helical path. But let's try to further see what sort of helical path would it be. The first thing is, say, due to magnetic field, it would be a circle with this nature, because V cross B would give the direction of center, and the electric field would drag it along positive Z direction. So it would precisely be a helix whose pitch is increasing. So for question number 14, the correct option is option number C. Now let's go to the last question on the basis of this table. Question number 15, and the last question corresponding to this table, it's something like this. In which case will the particle move in straight line with constant velocity? Constant velocity के condition हमने maintain करनी है. इसका मतलब straight forward है. Net force should be equals to 0. And the net force here is quite obviously QE plus QV cross B. जो भी given condition would find this given force to be equals to 0, that will ensure the particle would move with constant velocity. So it's a very straightforward question. आप solve करें with all this given possibility. Option number D would come out to be correct. So D is the correct option for question number 15. So we end up this particular table, and the next triad of the question number 16, 17, 18 is also of the same variety. Let's move on.